In this video, we're going to look at writing a chemical equation for an acid-base reaction. And this example is on page 224 in the textbook, and it's example 7.11. And we're doing this, or I'm doing this because there is a misprint in the 5th edition chemistry book for this question. So first of all, this is an acid-base reaction because we have HNO3, which is nitric acid, and we also have calcium hydroxide, which is our base. So because this is an acid-base reaction, all acid-base reactions create water in its liquid form. So we can write water right away as one of the products. And I've zoomed out a bit just to give myself a little bit more room. And then looking at what we have left, if our hydrogens, if the hydrogen from the acid combines with the hydroxide from the base to create water, then we're going to have calcium and the nitrate left over. So calcium and NO3 aqueous left over. And to find out what the ratio of calcium is to the nitrate, we know that calcium has a charge of +2, and we know that nitrate has a charge of a -1, polyatomic ions. Bring those charges down, that's going to give us our subscripts. So it's going to be 1 calcium for every 2 of the nitrates. Now this is the skeletal formula for this acid-base reaction. So here we have the acid combining with the base, and then the H from the acid and the hydroxide from the base will combine to create our water, which is H2O. And then the calcium, which is the positive ion from the base, will combine with the negative ion from the acid, which is NO3. And we put those together with the appropriate charges becoming the subscripts by doing that reverse cross method. And then we have the ratio of calcium to nitrate. Next, we need to balance this equation. So in balancing the equations, what I want to do is make sure that I have the same number of atoms for each element on both sides, the reactant side and the product side. And the order that I'm going to balance them in is, I'm going to do the calciums first, as they are the metals. I'm going to do the polyatomic ion NO3 as a unit because the NO3 does stay intact on the reactant side and the product side. Then I'm going to do my oxygens and my hydrogens. Now my oxygens are also included in the nitrate, but that's okay. I'm going to also piece them out separately as well. So on the reactant side, I have 1 calcium. And on the product side, I also have 1 calcium. On the reactant side, I have 1 nitrate. And on the product side, I have 2 nitrates. And you can see that right here, I did have the subscript of 2. For oxygen, on my reactant side, I have 3 oxygens here. And then I'm going to have 2 with that OH. That 2 does apply to the O. So that means I have 5 oxygens all together on my left. And then on my right, I have 1 oxygen here. And 3 times 2 gives me 6 oxygens. So that's going to give me a total of 7 oxygens on my product side. And then for hydrogens, I have 2 hydrogens here, plus 1 is going to give me 3 for my reactant side. And then on my product side, I have 2 hydrogens here. So the calciums are already balanced, so I'm going to move on to my nitrates, and I have 2 nitrates on my right, so I'm going to need 2 nitrates on my left. So I'm going to put a 2 in front of my nitric acid. That's going to change my nitrate count to 2 now, but it's also going to change my hydrogen. That 2 gives me 2 hydrogens here, plus 2 hydrogens here give me 4 hydrogens altogether on my reactant side. So now to balance, now that my calcium and my nitrate are balanced, I'm going to balance my oxygen and my hydrogen. I'm going to do my hydrogens first because the oxygen are spread out between the nitrate and the oxygen by itself in the water. So for hydrogen, I have 4 on my left and only 2 on my right. So if I put a 2 here in front of the water, that's going to give me 4 altogether for my product side. It's also going to change up my oxygen. I'll have 2 oxygens within the water, and then that's plus the 6 that are found here with the nitrate. So that's going to give me a total of 8 altogether. And that actually balances out because I forgot to, when I put the 2, in front of here, I did my change in my nitrate, I did my change in my hydrogen, but it also changes my oxygen as well. 2 times the 3 oxygens here give me 6, plus 2 oxygens here give me 8. And so that now balances out. So by putting the 2 coefficient in front of the acid and the 2 in front of the water, that balances out the equation. So this becomes my molecular equation. It's balanced, it has the complete ionic compounds together, and it also has the state that they're in, whether they're aqueous, liquid, solid, or gas. Now to write the net ionic equation. For the net ionic equation, what I need to do first is I need to do just the complete ionic equation. So I want to take my acid and put it in the ionic form. So that's going to be 2H plus aqueous plus the 2NO3 aqueous, which are my negatives, plus Ca plus aqueous is the calcium, the positive ion from the calcium hydroxide, plus my negative hydroxide ion, and that's going to create my 2H2O, which stay together. Whenever I write my complete ionic equation, I need to keep my liquids, gases, solids together. And then I'm going to have calcium, positive 2 aqueous, plus my NO3 to negative aqueous. So that's my complete ionic equation. And then lastly, for my net ionic equation, I want to pull out the water, which is my precipitate, H2O liquid. And then I only want to take the ions that are brought together to make the water. So that's going to be my OH and my H. So 2H plus aqueous plus OH to negative aqueous. And that is my net ionic equation for my acid-base reaction.